Hello and welcome to Fun with Physics with Uncle Bob. This week we'll be looking at the Jeep or expedition problem using multiple Jeeps. So go ahead and read the problem statement you see here. Pause your video and see if you can solve it yourself. I'll be back in a moment with my solution. Here's my solution. We start here with 3 Jeeps going to this point, D1, and refilling 2 Jeeps completely, allowing them to go on, leaving just enough gas in 1 Jeep to get back to the start or base camp, running out of gas right here. These 2 Jeeps that are filled up here, D1, F1, F standing for fuel going forward, D standing for this distance right here. 2 Jeeps go forward. Again, one of the Jeeps continues on after being filled up completely. One returns here. At this point, the Jeep that returned firstly fills up again at base camp, goes out and meets or rescues this Jeep, which is often running out of gas about here. Again, this point will be called D2. F2 will be the amount of fuel remaining at point D2 in this 1 Jeep returning. These 2 Jeeps meet, go back to base camp, refill, go out and meet this last Jeep returning here, 3 Jeeps coming back. D3, F3, to continue here, we've got 1 Jeep going out to our optimum or maximum point called D5. D5 will be maximized in the math and the program written in Power Basic. The object is to get D5 as large as possible while allowing these Jeeps and the final Jeep to never turn back, or at least the final Jeep keeps going and then turning back to be met here by the rescue Jeeps. The conditions in math are given down here. You can read through them and briefly again the terminology. D is distance from the start for each of these points. F will be fuel on this side of the bar. In other words, we've got 2 Jeeps leaving with an amount of F1 fuel right here. Going here and returning back, arriving at this point with F2 amount of fuel. Same here, F3 fuel coming back, F4 amount of fuel for this Jeep at this point. Here's the math and conditions. Let's look at the software with these equations written in Power Basic. Here's that program written in Power Basic. I'll scroll down so you can see the entire program before I explain it. This is the end, the bottom, where it says end function. If you want to pause and look at this further or copy it, feel free. Go back to the top. Scroll down to the bottom. There we go. What this program does is vary D2, D3, D4, and D5, our respective distances from the start as you saw previously. This is the final iteration with relatively very small step sizes and small intervals for each of these. When I started 2 or 3 generations or tries ago, these intervals were rather large and the step sizes were rather large. I've narrowed it down here, converging on a solution manually. This did not take very long. Here is the math, which you've seen previously, along with limiting conditions on this line. The object, again, is to maximize D5, the furthest distance 1 Jeep can go. So again, here's that program. Let's go ahead and run it. Here's the solution. D1 through D5 are given here. What we're interested in is D5. That's the maximum distance one Jeep can go. That turns out to be 1 unit distance. Our fuel is listed here, F1, 2, 3, and 4. Notice F2, F4 have 0, indicating at points D2 and D4 that returning Jeep has just run out of fuel to be rescued by the Jeep coming back, rescuing them from base camp. This last line indicates an earlier previous solution to this problem, which is somewhat well known, where Jeeps will peel off or return to base camp, but not go back to rescue any Jeeps. So this solution leads to a distance D5 of 0.75. By using the rescue protocol, in my method we've just gone through, again, we can get a unit distance of 1 with that method versus 0.75, so we've increased the maximum distance we can get one Jeep. So that's all for this week. Hope to see you next time on Fun with Physics with Uncle Bob. You might want to try this methodology using 4 or 5 Jeeps. See what you can do.